Our next speaker is going to be the incredible Gongbo Tang. Gongbo has a Master of Engineering from Beijing Language and Culture University, and then he did his PhD titled Understanding Neural Machine Translation at Uppsala University, and I had the honor of being on his committee. After that, he joined my research projects on pronouns and MT as a postdoc, and I can honestly say that he's given this project an incredible boost, especially in the modeling part. Very sadly, today is his last working day in this project, and I'm very, very sorry to lose him. But I'm also happy to say that he's moving on to greener pastures, as he will start a faculty position at Beijing Language and Culture University very soon, and he goes with all my best wishes. Gongbo's talk today is about cross-lingual coreference resolution models and pronoun translation with mention attention. Please, Gongbo, the floor is yours.
Thanks for your introduction. Yeah, I'm really happy to be working with you. And okay, so as just introduced today, I will just talk about my work in the project. So this consists two parts. The first one is cross-lingual coreference resolution models, and the second half it would be the pronoun translation with the mention attention. So let's start it from the first one, the cross-lingual coreference resolution models. And coreference resolution is the task of finding expressions that refer to the same entity in a text. So here is an example. EMLP 2022 is coming. It is a top-tier NLP conference. So here it refers to EMLP 2022. And this pair here, we just the green line is kind of linking these two missions, and they can be called a coreference link, or in this sentence, it's a coreference chain. And with the development of pre-trained language models, these neural coreference models are de facto models in coreference resolution area. But on the other hand, these neural models need a lot of annotations, but on the other hand, annotating these coreference annotations is quite expensive. And currently, most of the neural coreference models are only trained on the monolingual data, because these coreference annotations are only annotated on the monolingual corpus. And Hadmir et al. Have shown that the parallel data contains latent anaphoric knowledge, which is kind of before the neural deep learning stage. And here is an example of a coreference chain in an English-Chinese parallel sentence pair. So compared to the two monolingual sentences, there are more coreference links in this example. For example, the 8 in the English is also linked to the EMLP 2022 in the Chinese sentence, and also ta in the Chinese. So we are having more coreference links, and it's potentially will be beneficial for the coreference modeling. And so we asked, can parallel data advance the performance of coreference resolution on English, where large amounts of annotations are available? And so now we first start from the introduction of the neural coreference models. So it usually consists of 3 modules. The first one is the encoder, and the second one is the mention score, and the coreference score is the third one. So let's look at the more detailed illustration. So at the bottom is the word embedding of the text, input text, and then it will feed into the encoder. So here in the figure is the bidirectional LSTM, but nowadays people just use transformer models and performs better. Then the output of the encoder will be calculated and to form the span representations here in this line. And then this span representation will feed to the mention score and to generate the mention score for each span. And then for the coreference score, it will compute how likely a pair of mentions are coreferential based on the mention scores and antecedent scores. And so since we want to make use the parallel data, and so we proposed a cross-lingual coreference model, which models both languages. So if we look at the model architecture, so compared to the coreference model, our model just do the modeling on the both source and the target documents, and we introduce adapters to the target side to model the target side language. And the most significant difference is marked in red, and which we call it cross-lingual coreference score. So compared to the coreference score in the monolingual model, so here the cross-lingual coreference score, they compute the coreference score between source mention and target mention instead of two mentions in the same language. And we assume that there's at least one corresponding mention in a target language. And we also introduce cross-lingual coreference laws. And during training, we just combine both the coreference laws from the source side and also the cross-lingual coreference laws for training with a ratio of 1:1. And for our experiments, we mainly conduct the experiments on the OntoNotes 5 English datasets. And for when we train our cross-lingual coreference models, the parallel data are generated by pre-trained NMT models, and we apply the widely used evaluation metrics for coreference resolution, the MILC, B-cube, and the SAFE. For the text encoders, because we are working on two different languages, so we first apply the XLMR, and but we also test our model with two separate monolingual pre-trained models as well. So here are the experimental results. So the baseline is a conventional coreference model, which is only trained on the English dataset. And for our cross-lingual model has been trained on 9 different synthetic datasets. And the target languages include Arabic, Catalan, Chinese, Dutch, French, German, Italian, Russian, and Spanish. So if we look at the last column, we can see that our cross-lingual coreference model achieved consistent improvement. And the improvements on the F1 score can be up to 1.74. And so these results can confirm that parallel data can provide additional coreference knowledge, which benefits the coreference resolution. So now we have shown that our cross-lingual coreference model could learn more coreference knowledge, but we would like to explore the ability of this explore the unsupervised cross-lingual coreference score module. Specifically, we let the cross-lingual coreference score predict target side coreferential spans given a source mention. So when we check the predictions, we found that some of them are coreferential, but most of them are irrelevant. And because there are no data annotated with this annotate coreference alignment, so we can't do the automatic evaluation. So instead, we conduct a quantitative evaluation on a synthetic English-to-English pair, where the source sentence and target sentence are the same, both English sentences. So then we can get the aligned coreference chains. And here are the results. So we found that there are 131 predictions are the same mention as the source mention, and 1,257 are coreferential with the source mention, and 758 predictions has the same surface with the source mention, but the rest of the predictions are clearly irrelevant with the source mentions. And here are some examples that correct coreferential mention pairs predicted by the cross-lingual coreference model in English-to-English and English-to-German settings. For example, in the first one, so the source mention is Hong Kong, and the prediction in the target side is the cities, which is correct in the document. And say that in the last example, the 19-year-old American gymnast in the source side, and the prediction is Semney-Beres, and this is also correct in that document. So as I mentioned earlier, that because we are training this cross-lingual model on two different languages, so the first choice is using a cross-lingual multilingual pre-trained models. However, because of the curse of multilinguality, in general, the monolingual pre-trained models are more powerful compared to the multilingual pre-trained models, especially in the rich resource settings. And so we further replace the XLMR with Spanbird and BERT, and we train models on the English-German synthetic datasets. And our cross-lingual coreference model can achieve a significant improvement. The F1 score has been improved from 17.26 to 17.79. And to conclude, so the parallel data benefits neural coreference resolution, and the unsupervised cross-lingual coreference module can learn limited coreference knowledge. So we are thinking that could this cross-lingual coreference module learn more coreference knowledge if we feed some kind of supervision about the cross-lingual coreference alignment? Since there's no existing coreference alignment, so we decided to make it by ourselves. And then we move to the second part, the coreference chains alignment. And our work is mainly based on the ParCorFull, or more specific, ParCorFull version 1. And so, as I mentioned, the coreference chains annotated in the ParCorFull is kind of, they are annotated separately and not aligned. So we, in addition, if we have this aligned coreference chains, they can not only provide supervision for our cross-lingual coreference models, they can also benefit to understanding and modeling pronouns across languages. So here's a methodology of our automatic alignment methods. So first, we generated the mentioned representations from pre-trained coreference resolution models. And then we compute cosine similarity scores among mentions in coreference chains. And then we align coreference chains based on voting mechanism. Specifically, so given a set of mentions from a coreference chain, so each mention will be aligned, will have a candidate's alignment in the other side. And the candidate alignment has the most alignments, they would be chosen, will be selected as the alignment of the current coreference chain. And we conduct this alignment bidirectionally, and we select the intersection as the final alignment. So for the evaluation, we conduct a manual evaluation, and with the help of Max2 annotation tool. And here we report a record of aligned coreference chains after removing the problematic chains. So we can say that there's almost the same in two languages, in English and German, but there are quite big difference across the subcategories, subsets. For example, in the TED and the discourse subsets, the record is only like around the 64, and but in the news domain or subsets, the record score could be as high as could be higher than 85. And the reason why there's a huge gap is that the documents in the news subsets is usually much shorter and than the documents in TED and discourse MT, which are the TED Talks. And on the other hand, the other reason is that the coreference chains in news is relatively easier than the coreference chains in TED Talks. In addition, we also count the ratio of unaligned chains. So we can say that German has a higher ratio of unaligned chains, and in both languages, there are around 1/3 coreference chains has no alignment. So to conclude, the automatic coreference chains alignment is still challenging, especially for the documents getting longer. And there are also challenges in annotations, especially there has some kind of language divergences and annotation consistency. And we will release the updated version in the future. And the third part is the last part is pronoun translation with mention attention. And MT models have achieved the greatest success. However, the pronoun translation is still challenging. And this is mainly caused by the divergences of pronouns across languages, the agreement in gender and number, and the ambiguity of pronouns. In general, the antecedents of pronouns are crucial for pronoun translation, and paying attention to the incorrect antecedent can cause mistranslation. So we ask, can we extract additional contextual mention features to help pronoun translation? Because most of the antecedents belong to mentions. So let's have a quick review of the transformer NLP model. So it has an encoder and a decoder, and the decoder has an encoder and a decoder attention to extract features from the encoder side, from the source side. And now, so in order to extract additional mention features from the source, so we introduce the mention attention module. So compared to the transformer model, so the differences are marked in red. So we introduce the mention classifiers and also the mention attention module. So now in the output of the transformer encoder is not only fed to the encoder decoder attention, but also to the mention classifier and also to the mention attention module. But we apply the mention masking so that we only pass the mention features to the mention attention module. And also the output of the first feed-forward module also feed to a mention classifier to predict whether they are classified or not, or whether they are mentioned or not. And during training, we consider all these three losses, and we, with the ratio 10 to 1 to 1, and we assign a higher weight to the translation loss. So for the experiments, we conduct on the English to German direction and use the WMT share, the training data from WMT shared task. We use blur and APT scores for general evaluation and pronoun translation. The ambiguous pronoun set has 8 and they. So here are the blur scores and APT scores. So compared to the baseline, our model achieves better performance on the blurs and APT scores. In particular, the improvements on the ambiguous pronouns are higher than that on the 4 pronoun set. This results show that our model with mention attention can help pronoun translation, especially for the ambiguous pronouns. And at the beginning, we also conduct experiments on the IWSLT dataset, but we kind of get different results. So, we also conduct contrastive evaluation using the ControlPoll test set. But we found that even a model with lower blood scores, they still can achieve very competitive contrastive evaluation scores. So if we only using the contrastive evaluation result for evaluation could be misleading. And we also extend to other language pairs as well, but right now we only get some preliminary results, and the findings are not consistent over different language pairs. So we would do more development and experiments. And this topic is kind of have been discussed in the previous talks. So as the words and disambiguation and pronoun disambiguation is kind of similar, and it potentially could be useful for the pronoun translation if we model these ambiguous pronouns and ambiguous and lexical ambiguities together. So yeah, that's all. Thank you.
Thank you very much, Gongbo. Have we got any questions from the audience?
Any comments are also very welcome. So the last part is kind of still undergoing, and some experimental results get lost because the hard disk got broken. So I only report part of the existing results, and you're welcome to give more suggestions or comments.
So I guess my question now, since this is your last day in my project, so in the future you will no longer be bound by my project plan. So what would you do completely differently?
What do you mean? You mean my
What
research?
if you were to research the same things, and so far since you were working in my project, you were obviously bound by the ideas I had in my project plan. But now from tomorrow on, this will no longer be the case. So do you have any ideas like where to go if you were completely
I
free
think I
from all
will first
constraints?
start. Sorry, I think I will first start like extending the last project, which is kind of we will go for the ambiguous pronouns and pronouns, and then we can extend to the more general ambiguity problem in translation.
Yeah, yeah.
I think that's still like even though we with more training data, more powerful neural network architecture, but they kind of still challenging and important. So that would be kind of one direction in the future.
Yeah.
And maybe more specifically, it could be like we'll follow kind of the work presented by Dei and Kyle. So we can. So here I'm kind of only present more very close, like contextual features that's limited with mentions. But in fact, it could be like a more dynamic features, like not limited by the mentions. So it could be propose something to learn or extract the most useful features for disambiguation or for pronoun translation.
And how would you figure out which these are?
So here, like I mean, they have give a kind of idea that give some kind of supervision about the linguistics supervision, and the other one is kind of just view the model as a black box because this attention module, they are kind of a black module, and they learn to extract features by themselves, and they are very powerful and adaptive. So if we could kind of apply these kind of attention modules to learn to further extract like contextual informations for the pronoun translation or ambiguation.
Mm-hmm. Mm-hmm.
Yeah.
Okay. Have we got any more questions from the audience? If not, thank you very much again, Gongbo, both for your presentation here and for all the work you've done in my project.
Thank you.
And then I hand over to you for sharing the last talk by Biao. Thank you.